Well, now let's explore linear inequalities and absolute value inequalities. Let's look at the first example. It says the cost to rent a motorcycle is $95 plus 35 cents for every mile that you ride it. You can spend at most $375. Let's say that's all you have. Let's say you have $375 in cash with you. Let's write an inequality that will model this situation. Well, we've got to have a variable. It's going to be x. X is going to be the number of miles that you ride. So, this statement right here, this phrase, at most $375, that means something has to be less than or equal. That's the same thing as at most. Less than or equal to $375. $375 is the most money you're able to spend. What we need on the left-hand side is an expression for how much money you're going to spend renting this and riding this motorcycle. So, it's going to be $95 plus 35 cents for every mile that you ride the motorcycle. I wrote 35x, is that correct? Not quite. This is in dollars. This is in dollars. So that needs to be in dollars. So it'd be 0.35x. This is how much money you are going to spend. It's going to, even if x is 0, you're going to have $95 to spend if you just sit on the motorcycle for the weekend. So this is the inequality that models this. And notice it looks almost like the equation of a line if we replace the less than or equal with just an equal. And what I meant by a line was a linear inequation, a linear equation with one variable. So now we've got this less than or equal, so that's really the only thing different from earlier sections. So let's go ahead and solve this. 0.35x is less or equal to, I have to subtract 95 from both sides, and that I believe would give me a 280. And then we divide both sides by 0.35, and we end up with, plug that in and you get 800. So what does this tell you? All it tells you is that the number of miles you can ride, x, has to be less than or equal to 800. So if you're riding this motorcycle away from the place that you rented it, you better not go farther than half of that because you have to get back as well. And you could actually, since x is the number of miles you ride, we can be a little more specific here. You can't ride a motorcycle a negative number of miles, so we could do it like this. So the number of miles you could possibly ride will be between 0 and 800. Okay, well, there is a convenient way to write this type of a range of numbers, and it's called an interval or interval notation. Okay, so for this, suppose that A and B are real numbers. I hope you've seen this terminology before. That is an element of, and this fancy R, it just represents all real numbers. So A and B are real numbers, and A is less than B. So on the number line, it would be to the left of B. Well, we got a lot of them to go through, but it's going to be very similar. The whole group will be very similar to each other. This interval from A to B, you put in parentheses, you put the two numbers in, you put a comma between them, the small number on the left, the bigger number on the right. It means all of the numbers that are strictly in between A and B. So the meaning would be the set of all x is a real number, such that x is in between A and B. And on the graph, there's two ways to do it. I'm going to do it the way I prefer. I'm going to put A here, B here. I'm going to put a circle on the A, a circle on the B, and shade everything in between it. The circles kind of imply there's like a hole in the graph there. B is not part of the shaded region. A and B are not included in these numbers because it has to be greater than A, less than B. Then we have, this is called an open interval, by the way. You don't have to memorize that if you don't want to. Open interval means you got parentheses on both sides. When you have a square bracket, it means almost the same thing, but you include the A and the B. So it'll look like this, less than or equals instead of less thans. And you use a solid circle. Now there's no hole in the graph there. A and B are included in this set, from A to B and everything in between. So let's do the next ones quickly. You could probably guess what this would be. A square bracket means the A is included, but the rounded bracket means B is not. So we'll have 1 less than or equal, 1 less than. And we'll have one solid circle on the left, and we'll have an open circle on the right. I'm not going to write A, B on every one of these graphs. Just remember A is here, B is here. All right, this one goes the other direction. A less than X, less or equal B. So open circle on the left, closed circle on the right, shade everything in between. So the A is not included, but the B is included. This one only has one variable. It goes from A to infinity. So that means that's from, let me do it on the graph first. A, which is not included in the set because it's a parentheses, you just shade everything to the right. And you could think of infinity is not a number, but it's a symbol that represents something bigger than all the real numbers. You could picture infinity being way out here. All right, so this just means that's everything. I'm going to put the A there for this one. It's everything to the right of A. All of the x's that are strictly greater than A. The next one's very similar, x greater or equal A. So you put a filled in circle, shade everything to the right. The next one goes from negative infinity on the left all the way up to B, but not including B because it's a parentheses. So I'm going to say everything B is about here. It's going to be everything from negative infinity up to B. So negative infinity would be the symbol way out here. Again, it's just a symbol that represents something that is less than or to the left of every number on the number line. And let's see, like this would be to the left, so it's going to be all of the x's that are less than B. This is B right here. This one will be just x less than or equal to B. So we put a solid filled in circle there, fill into the left. And the last one, well, I don't even know why I put this one on here. The interval from negative infinity to infinity is actually what this symbol is. It's all real numbers. It's the entire real line. So I'm just going to replace this, a set of all x such that x is an element of the real numbers, and it's the entire real line, negative infinity to infinity. Again, that one was optional. I maybe should have left that one off. Okay, one very simple, to finish up this video, one simple example. Express this interval in set builder notation and graph it on the real line. Well, this is all of the x values, all numbers on the real line that are between -1 and 3, that includes -1 but does not include 3 because you have a square bracket only on the left. So I'll do it first. It's very simple on the to graph it on the real line. Put a -1 there, you put a 3 there, solid circle on the -1, open circle on the 3, and then you fill in or shade everything between them. That's all of the numbers that are shaded from -1 all the way up to but not including 3. So in set builder notation, that is just the set of all x such that x falls in between -1 and 3, but I put a less than or equal on the first one because it could be -1.